So you treat these the same way as you would if it was a square root. Okay, so remember, we just work backwards. So if x is equal to 2 and x is equal to 3 plus I, what is x, since you have an imaginary number, what is x also equal to? 3 minus I. Okay? So you're trying to work everything backwards. So I want to get everything to where everything is equal to 0. So each one is equal to 0 whenever I do this. So whenever I do, then what I'm going to have is I'm going to have x minus 2 equals 0. I'm going to have x minus 3 minus I equals 0. And then I'm going to have x minus 3 plus I equals 0. So what do I need to do with all three parts that are in green? Yeah, add the parentheses and multiply them together, right? So I'm going to have x minus 2, I'm going to have x minus 3 minus I, and x minus 3 plus I. Now, which two are going to be the smart two to multiply together first? The i's, right? Okay, because the i's are going to, the whole point of doing that is to get the i's and everything else to go away. Okay, it's still going to give you a value, it's still going to give you a quadratic, but at the same time, it's going to give you values that are going to turn into real values. So again, what I would suggest whenever you do this, it's completely up to you how you do it, but I would probably just go ahead and put them in and do a 3 by 3 and put it in a kind of in the box. Okay, I just think it's easier to kind of hold everything together. You don't have to do it this way, but I'm going to go x, I'm going to go negative 3, and I'm going to go negative I. And I'm going to do the same thing, and I'm going to go x, I'm going to go negative 3, and I'm going to go positive I. So then all we're going to do is just multiply everything together and kind of fill in my tic-tac-toe board. So if I have x and x, I'm going to have x squared, negative 3, and a positive x is going to be a negative 3x, and then a negative 3i. Do the same thing in the second row and the first column, or every single column. So I'm going to have a negative 3x, I'm going to have a positive 9, and then I'm going to have a positive 3i. My mistake, looking at the wrong thing. So it should have been a negative ix. My bad. Do the same thing again, going for the bottom column. Fellas, middle table, I'd appreciate it. Do the same thing again, but do the bottom row with everything along the top. So positive ix, negative 3i, and then negative I and positive I is going to give me a negative I squared. What is negative I squared, though? It's going to make it a positive one. Okay, because it's a negative. That's a negative of a negative 1, which is just going to make it a positive 1. So combine anything that can combine. What's going to happen here and there? They're going to cancel. What's going to happen here and here? They're also going to cancel. So then it just becomes putting everything together that can match. So I only have one x squared, so I'm going to have an x squared. I'm going to combine my x's. So I get a negative 6x. And then I'm going to take that positive 9 and the positive 1 and have positive 10. Now all I have to do is take the x minus 2 that I had, Okay, and again, if you want to put it in a box or put it in and kind of do it in your table this way, do it that way. Do it whatever's going to be easiest for you. And take the x squared minus 6x plus 10 and multiply it with the x minus 2 that we got there. Then it's the same type of problem. So all we did, we just took what we got left from the two imaginary terms when we multiplied those two together, and then we got that trinomial. We just multiplied it with the x minus 2 x minus 2 binomial that we had at the beginning. So whenever I do that, I get x to the third, and then negative 6x squared plus 10x minus 2x squared plus 12x, and then minus 20. Combine anything that can combine, so we can combine here and we can combine there. So what should happen is whenever we're left with everything, should be left with an x to the third minus 8x squared plus 22x minus 20. Again, I think it told us that everything had a lead coefficient of 1, so we didn't have to multiply anything through, and we go from there.